the icy depths of Antarctica, beneath a blanket of ice, lies a detector sensitive enough to capture one of the universe's most elusive particles, the neutrino. But not just any neutrinos. We're on the brink of unearthing the ancient whispers of the cosmos, the cosmic neutrino background. These ghostly particles are the newborn cries of the universe itself, a faint echo from the Big Bang that has stretched across time and space, reaching us as a whisper from 13.8 billion years in the past. What makes the cosmic neutrino background so astonishing is that it's everywhere, and yet it's managed to evade our grasp until now. These are the survivors of the earliest moments following the Big Bang, a time when the universe was an unfathomably hot, dense point. As the universe expanded and cooled, these neutrinos decoupled from the rest of matter and have been traveling unimpeded ever since, creating a sea of near invisible particles that permeates everything, including us. Understanding these primordial neutrinos is akin to finding the holy grail of astrophysics. They hold secrets to our universe's infancy, before stars and galaxies even form. They could potentially unlock mysteries about the fundamental forces of nature and offer insights into the behavior of the universe at its most extreme. But for decades, the cosmic neutrino background has slipped through our fingers. Recent advancements have brought us to the cusp of a breakthrough, with experiments like IceCube Neutrino Observatory in Antarctica leading the charge. Picture a cubic kilometer of pure ice, instrumented with thousands of sensitive detectors, capturing the tiny flashes of light produced when neutrino interacts with an atomic nucleus. It's a hunt for the briefest of encounters that can tell an epic spanning tale. The rarity of neutrino interactions is what makes them so hard to study, but also so valuable. They barely interact with matter, passing through planets, stars, and even us without a trace. It takes a detector of incredible scale and sensitivity, biding its time in the eternal cold, to capture just one of these interstellar messengers. As we edge closer to confirming the cosmic neutrino background, the implications are profound. This discovery would not only reinforce the Big Bang theory, but could provide evidence for the existence of the theorized process of leptogenesis. This is the idea that a slight asymmetry in the behavior of neutrinos in the early universe led to the dominance of matter over antimatter, essentially explaining why we and everything we see around us exists. Furthermore, these findings have the potential to challenge or uphold the standard model of particle physics. The standard model is our best explanation for how the fundamental building blocks of the universe interact, but it isn't complete. Neutrinos could be the key to unlocking new physics beyond the standard model. Their mass, for one thing, is not accounted for, and yet they have mass, despite early assumptions that they might be massless. But how does one capture something that's omnipresent yet nearly impossible to detect? We leverage the sheer volume of these particles, and we get creative with technology. Detectors like those buried in Antarctic ice are not the only way we're chasing down the cosmic neutrino background. There's also the ambitious plan of using the moon as a neutrino detector by observing neutrino-induced radio pulses coming from its surface. These are big dreams, but then again, it's a big universe, and neutrinos are a massive part of that story. The journey to detect the cosmic neutrino background also brings together a symphony of disciplines: astronomy, cosmology, cosmology, particle physics, and even geology. It's a reminder that the quest to understand the universe is a collective human endeavor, transcending boundaries and uniting us in our curiosity and ambition. Now, imagine the day we confirm the cosmic neutrino background. It will be a snapshot of the universe in its infancy, the first seconds after the Big Bang, frozen in time, but recorded in the language of neutrinos. We'll have a new lens through which to view the cosmos, with neutrinos guiding us towards a better comprehension of our universe's past and perhaps its future. This pursuit is the perfect blend of human tenacity and cosmic serendipity. It's where science fiction meets science fact, where tiny particles that have journeyed unaltered for billions of years could hold the answers to the grandest questions of all. How did the universe begin? What is it made of, and what is our place within it? With the cosmic neutrino background, We are not just observing the universe, we're listening to its very heartbeat. The quest to understand the cosmic neutrino background is not just about reaching a scientific milestone. It's about adding a new chapter to humanity's age-old narrative of exploration. It represents an unrivaled adventure, a cosmic detective story with each discovery a clue that brings us one step closer to unraveling the most profound mysteries of the universe. The neutrinos have been silent witnesses to the entire history of the cosmos, and now we stand on the threshold of tuning in to their ancient stories, forever altering our understanding of the space and time we inhabit.